The second basic differentiation rule will be the power rule. The power rule tells you how to differentiate x to the n, where n is a real number. And the derivative with respect to x of x to the n is n times x to the n minus 1. Multiply by the old exponent and subtract 1 from the exponent. For example, let's say you want to differentiate root x. Root x is x to the 1/2, so we first express that using rational exponents. Essentially, you want to express x as a power in order to use the power rule. Then we multiply by the exponent and subtract 1 from the exponent. And if you want to simplify, by all means go ahead. 1 over 2 root x is the derivative of root x. And the geometric interpretation of this is not completely obvious, but the derivative is slope. And slope gives you the change in y over the change in x. Now in this example I just did, the function y was root x. So the function y had exponent 1/2. And we took the quotient of that with the change in x. The change in x is just a linear expression, so the exponent's 1. And when you take the quotient of two exponential terms, you subtract their exponents. 1/2 minus 1 gives you negative 1/2. So when you do the derivative of a power term, you take 1 off the exponent because you're finding the slope, which is the quotient of the change in the function over the change in x, a linear term. And when you divide by that linear term, you subtract 1 from the exponent. The algebraic proof, the proof that uses the limit definition for derivatives, is a bit trickier to understand. Well, first let's set it up. So our goal is to prove this. The derivative of x to the n will give us n times x raised to the n minus 1. So we know the derivative is the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x, just the change in the function over the change in x as the distance between our 2 points gets infinitely small. Our function f is x to the n, so we plug these into our function. F of x plus delta x is x plus delta x to the n power minus f of x, which is x to the n. And next we want to expand this binomial. So there is a theorem called the binomial theorem, which tells you how to expand binomials. I can post an extra video detailing how that theorem works and how these coefficients come into play. But if you've ever heard of Pascal's triangle is useful in the binomial theorem, as are combinations. I'll make sure to post an extra video that details the binomial theorem. But all that we really care about for the proof is that if we were to expand x plus delta x to the n power, it would give us x to the n plus n times x to the n minus 1 delta x plus another term, which is n choose 2 x to the n minus 2 delta x squared plus dot 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 all the way to delta x to the n power. So this is the expansion of that binomial term. This right there is a combination which you may not be familiar with yet. If you aren't familiar with it, don't worry. And if you're curious, as I said, I'll post a video about it as well. But we have this minus x to the n, which I'm going to write so tiny, all over delta x. What happens now is a whole lot of cancellations. X to the n minus x to the n, those cancel out. And now every single term that's left on top has at least a power of delta x in it. That's delta x to the first, that's delta x squared. The next term will be delta x cubed, all the way up to delta x to the n. So we can divide everything by delta x. So all these powers of delta x get subtracted by 1. And we can now take the limit, because we no longer divide by 0 when we plug 0 in for delta x. And so, when we plug in 0 for delta x to all the ones on top, we see this first term no longer has a delta x. so it's just x to the n minus 1 times n. But every other term in the numerator will have at least 1 power of delta x. So all these will go to 0. So everything else cancels out. This is all that's left. Probably the more important thing to know is the first explanation I gave, the geometry of it. How when you divide by the change in x, you divide by a linear expression, which means you divide by a term with exponent 1, and when you divide, you subtract your exponents. That's why you subtract by 1.